Okay, guys, welcome. In this video, we're going to talk about combinations, or another way you can think of this is that this is just the number of subsets of a given size. Now, the number of subsets of size k from a set of size n would be n factorial. I'm just going to say it in this compact form. It's n factorial divided by k factorial times n minus k factorial. And a lot of times we will just write this in this form, and a lot of times this is read as n choose k. So if you hear me say like 10 choose 3, that's what I mean. Okay. Now the proof of this is to sort of use the fact that the number of ordered sets would be n factorial over n minus k factorial. Now, what you have done here is that if you want the unordered sets, right? So in other words, by unordered, we mean that ABC is the same as CBA, right? Because the order doesn't matter, right? So those contain the same elements, so we consider them to be the same sets. Now, there are k factorial ways to scramble those letters. So if you want the unordered sets, you've overcounted by k factorial, right? So if you divide this out, then this would give you the result that you would want for unordered subsets. All right, and of course, we'll later see that n choose k also end up being what are called binomial coefficients. All right, now to see an example of these combinations, in how many ways can a 3-person committee be chosen from 12 people? Well, since the order does not matter for a committee, this is just 12 choose 3, which will come out to be 12 factorial over 3 factorial 9 factorial. And a lot of times, again, you could leave the answer in either one of these two forms. If you wanted to keep going, however, you could say this is 12 times 11 times 10 times 9 factorial over 3 factorial times 9 factorial. The 9 factorials would cancel out, and we would get a 1210 over a 6, which may or may not divide cleanly. I guess actually it would have to divide cleanly, right? And if we were to divide that, let's just see what we get. Divided by 6. Let's see, am I doing something wrong here? Let's see, 12 times 11 times 10. Oh, is 1320. That's why I'm messing that up. And then if we divide that by 6, we would get a 220. All right, so that's why that would work out that way. Okay, so what I now want to show is that n choose k is the same as n choose n minus k. Well, n choose k, we just saw was n factorial over k factorial times n minus k factorial. Now, n choose n minus k would be n factorial over n minus k factorial, and then times n minus k factorial. But if you simplify this, you're going to get that this is n factorial over n minus k factorial times k factorial. And of course, these two are the same thing. Okay, now this next example, you can show either using a combinatorial argument, or you can show this just using algebra. All right, so let's show it using algebra first. Well, we know that if I want to take n minus 1 choose k minus 1, this is n minus 1 factorial over k minus 1 factorial. And then we're going to have an n minus k minus 1 factorial. Okay, now this next part will be a plus n minus 1 factorial over k factorial, and then an n minus k factorial. Well, let's clean this one on the left up. Well, that will give us an n minus 1 factorial over a k minus 1 factorial, And then if we simplify here, we're going to get an n minus k plus 1 factorial. All right, so now it looks like we need to find a common denominator to add these together. Okay, so it looks like for this term, I would need to multiply the right side by an n minus k plus 1. Top and bottom, of course. Right? And then on the left side, because of this term, I would need to multiply the top and bottom of this by k. So it looks like we're going to get a k times n minus 1 factorial plus an n minus k plus 1, let's see, times n minus 1 factorial over, and then we get our k factorial, and then an n minus k plus 1 factorial. Okay, well now, if we expand this out, this will give us an n times n minus 1 factorial minus k n minus 1 factorial, and then plus an n minus 1 factorial. So it looks like these two will cancel. I'm going to be left with an n times n minus 1 factorial plus n minus 1 factorial over a k factorial times an n minus k plus 1 factorial. Okay, so we're almost done. So it looks like in the top we can factor out an n minus 1 factorial, and we're going to get an n plus 1. Right, and then that's going to be over a k factorial times an n minus k plus 1 factorial. All right, now if we're careful here, and actually I could probably do this instead. If I do n times n minus 1 factorial, that is n factorial. All right, so I have n factorial plus n minus 1 factorial. Okay, so now we're almost there, right? So what I need to do is I need to sort of get rid of I have an n minus k factorial times an n minus k plus 1. All right, so we need that factor to sort of go away. Now, let's see, how could we do that? Let's see. So I actually think, let's see, did I mess something up here? No, I think this is fine. Okay, no, that's good. Okay, so we need to get this n minus k plus 1 out of here. So how could we do that? So if I were to leave it, let's see. Okay, we're going to backtrack here because I see that I made a mistake. So let's erase this. So when I found this term right here, I forgot the n minus 1. So it's actually going to become just an n minus k factorial. So it's going to make our life a little bit easier. So let me backtrack it here. All right, here we go. Okay, so let's rewrite this here. Okay, here we go. Okay, so what this should be n minus 1 factorial over a k minus 1 factorial, and then an n minus 1 minus k minus 1 factorial, which will then make this become n minus 1 factorial over k minus 1 factorial. And then my 1's will actually cancel out, and I'll just be left with n minus k factorial. And then still this from before. Okay, so now in order to add these, now all that I need to do is I need to multiply the top and bottom of this one by k. Right? So now what will happen is now I can write this all over k factorial times an n minus k factorial, which is what we want in the bottom. And then we have a k n minus 1 factorial plus an n minus 1 factorial. Okay, so now, of course, what can we do? Well, we can now say that this is an n minus 1 factorial times a k plus 1, now over a k factorial times an n minus k factorial. Okay, so now, again, the whole idea is we want to show that this is equal to n choose k, which is n factorial over over k factorial times n minus k factorial. Okay, so now let's see, what can we do here? So it looks like what we're going to have is, and it looks like I actually forgot my minus 1 on this side too. All right, so sorry about that. Okay, and then this should be an n minus 1 minus k factorial, so n minus k minus 1 factorial. Okay, so it looks like I would need to multiply the top and bottom of this one by n minus k. Okay, that should do it. So we get n minus k there. So then, finally, we can say that this is equal to a k times an n minus 1 factorial plus an n minus k times n minus 1 factorial over k factorial n minus k factorial. Well, now if we multiply this second term in the numerator out, we're going to get an n times n minus 1 factorial minus a k times n minus 1 factorial. Well, now these cancel out, and we're left with n times n minus 1 factorial, which is n factorial, over k factorial n minus k factorial, which is what we wanted to show. All right, so that completes the proof. All right, so that concludes this video on combinations. I hope you enjoyed, and I'll see you next time.